Good afternoon, manufacturing class. I decided to add this to the composites lab. So each of you are supposed to have looked through this instructions. This is posted on on Blackboard for the composites clipboard fabrication. So I have a couple of things that are listed here. Obviously, we're not doing this in person, but you're watching. So we will make a compression molded clipboard, and we're going to make a vacuum bagged clipboard, and we're going to make a simple vacuum bagged boat. Okay. That's in blue here. A couple of things. This goes through the instructions of what you need to do or would have done if you would have been here in person. So I recommend that you pause this, go through each section, and because this corresponds to what we did with what you'll see with the videotape. Okay. One thing you need to make sure you're aware that we mix the resin after everything else is ready. So before that, we need to calculate the amount of epoxy resin, epoxy hardener. And also, since the fibers take up some space, if we're going to estimate the amount of resin we need for something, we need to assume a fiber volume fraction. In this case, we assumed that was 35%. So 35% of the volume was taken up by the fiber. Okay, and so that's in our calculations. So we included that at some point in the video. We also took pictures of each of our calculations. Okay. Some other things here. The second week, there's a couple of things. We're compressing this all down into 1 week. So the trimming, sanding, applying a second coat of epoxy, all these things are included here. Or it will be all in 1 week. Okay. Let's stop there.
Hello, mechanical engineering manufacturing course. We're trying our first video on how to do composites. I've got the mask on, so I'm not contaminating these guys. Anyway. You will have a copy of our composites manufacturing sheet instructions, and that will be part of your lab report. So we're going to be making a composite clipboard, and we're going to be using 2 methods. We're going to be doing the traditional method where we're using vacuum bagging, and also we're going to be using an aluminum mold to do a compression, or not compression molding, but to do it with a heated press. It's still composite one. Also, we're going to be making some simple composite boat, and so these are some from last semester. These will, and so we'll get into that, but you should have the instructions for these. So these 2 work pretty well, except for when I was trimming this one, I trimmed there. That was my fault. This one, the students really didn't follow instructions. Okay. Okay. So for the clipboards, we're going to be using a 2 coarse pieces of cloth, one on each side of the foam core. We're going to be using 2 fine pieces of cloth. Those will be on the outside. And so it will be the same layup, stack up, whether it is for the vacuum pressed, or excuse me, the vacuum molded clipboard or the heated pressed one. Okay, for the boats, we're going to be using 2 layers on each side of the foam core for the boat, none of the coarser cloth. Okay, I'm trying to put together the foam core for this boat. It's a lot more complicated than the clipboard. And I'm not trying to be precise, I'm trying to show you the method. But if we were making a foam core for a real boat, we would have to have dimensions and make a paper template. But I'm trying to show you the process. And then if you're going to make a real boat. Anyway, I'm going to tape this cord together, and then I'll cut some fiberglass to drape over it.
Did I do mine too long? Did I do it too long? No. Not at all. Some of that is self-employed.
So I'm using a masking tape here because masking tape, or the epoxy we have, sticks to the masking tape. And so this is all going to be covered up anyway. the vacuum bag pressure will pull this down. And I don't need to tape up all these points because I'm going to have fiberglass on top and on bottom. Okay, so for the boat, we can use some straight pieces, but I have a bunch of scraps and they'll actually drape better. And so if we had a coarse piece of fiberglass, it'd be hard for that to drape over there, but these pieces are easier to drape. So I'm just going to cut a bunch of small pieces that I can drape across here. So we need enough for it to go twice. So I'm going to just do some small strips. We can have them go different ways. Enough said.
Here's the resin calculation that we need to do for the clipboards. We have our clipboard dimensions here. This is for the vacuum baggy one that I am doing. Patrick's is going to be a little different. But we have our clipboard dimensions here. We have our number of layers. So we have 2 thin fiberglass layers and 2 thick fiberglass layers. We have our thickness of a thin fiberglass right here. We have our thickness of the thick one, which is both that we'll need. Now we need to find the volume of each thin fiberglass ply. So we do length times width times thickness. We have that here. Now we need to multiply that by 2 because we have 2 layers. So here we do the same thing for the thick fiberglass, length times width times thickness, right here. Multiply that by 2 to get our total volume. Obviously we have our 2 multiplication here by each one, 2 plies. We get our total volume here for the clipboard. Then we have, so we're going to do a 65% matrix and 35% reinforcement of fibers. So our matrix is our resin and the reinforcement is obviously our fiberglass. So we have our volume of the epoxy, which is our 0.65, which is our percentage of matrix, times the total volume, and we get this, our volume of our epoxy. Then we have to get our density, or we have our density of epoxy, which is 1.11 grams, and we get our volume of epoxy in cubic centimeters. Then we get the mass needed, which is our total amount of epoxy needed, and it's right here. So if y'all go through this, it's the same thing like some of y'all's groups did on the polymer casting, and some of y'all casted epoxy. It's almost the same setup, except now we have fiberglass we need to take into account.
Okay, on the compression molded clipboard, you notice that Patrick has made the foam board so it'll fit exactly inside of here, but we're going to put another plate on top of this and it'll come down and touch this right here, and so we will have to make trim off a little bit around here, and each layer of fiberglass will also have to fit totally in the mold. So we'll have to trim the foam board down a little bit, and the fiberglass, at least the bottom layers, we'll have to trim them down so they'll fit in there. Okay, come on. So Aaron is measuring the peel ply, and the peel ply will be about 1.5 inches wider on each side.
And so we will need peel ply for everything we're making. So we'll need some sheets larger than both clipboards, and we'll have pill ply that goes underneath the boat, and we'll have pill ply that goes on top of the boat, the composite.
So here's the heated press. It's been heated up to 160 Fahrenheit. Here is the aluminum plate we're going to be used for our vacuum bagging. And we use aluminum plate so we can move it around. We could vacuum bag straight to a smooth tabletop, but for today we'll use aluminum plate. We have the chromate put around. So this plate has already been cleaned off with soap and water, and then it's also been cleaned with acetone. So I'm going to put some vacuum bagging sealant around. This looks like caulking, but it's not caulking. It's a lot more expensive than that. And the final stuff there. So I'll kind of close. Gotta pull the paper back and start this. So we can call this chromate or vacuum bagging sealant, and we're just going around the edge of our plate because we're going to use most of that. Okay, we'll make some dog ears, and because not everything's going to be flat. So Aaron is rolling it down. We want to make sure we have a good vacuum seal. All right, push it down there. We'll have a bump there.